Hello student, in this video we will discuss about the third allotropes of carbon, that is fullerene. So fullerene is made up by the C60 carbon atoms and its structure looks like football. And this the design of the fullerene are developed by the UK artist, that is Buckminster Fuller. So because of his name, the name is given, that is fullerene. Then student, we will discuss here about the saturated carbon compound and unsaturated carbon compound. So first one, what is the difference between them, we'll discuss here. So saturated carbon compound having only single bond, while unsaturated carbon compound having double and triple bond with the single bond. Then second difference is what, student? The saturated carbon compound is inert or unreactive as compared to unsaturated carbon compound, while unsaturated carbon compounds are reactive. Then student, if we burn the saturated carbon compound, so we will find the blue flame on burning, while the unsaturated carbon compound give yellow and sooty flame. Yellow means yellow color flame, but sooty means with the flame will find the smoke, black smoke over the flame. Yes, you can see this yellow and sooty flame when we burn the candle. Then student, the last and the final difference between the saturated carbon compound and unsaturated carbon compound, that is the saturated carbon compound having only sigma bond, while the unsaturated carbon compound having sigma and pi bond. Then student will here to discuss about the nomenclature of carbon compound. It's very important to give the name of any carbon compound. IPSC have decided some of the rule and regulation. So because to give any name to any carbon compound, we have to follow some rule and regulation. So first one I want to tell you, you have to, on the screen we can see, you have to learn all the name is given on the in this table. For example, for one carbon we need to say meth, for two carbon eth, for three carbon prop, but, pent, and so on. So as the number of the carbon will increase, so we need to remember this name of the carbon. Then student, on the basis of the type of bond, if single bond is there, so we give the common name, that is a alkane. The general formula of alkane is CnH2n plus 2. Then for the double bond here, alkene, yes, and general formula is CnH2n. Then for the triple bond we having the alkyne, yes, YNE, and the general formula for the alkyne is CnH2n minus 2. Yes. Now student, to give the general formula here for the giving the name of any carbon compound, that is 2p, 1p, word root 1s, 2s. So p means perfect, student. So we'll use prefix first in the carbon compound name. Then we need to use the second prefix, that is a cyclo. If ring is there, so we'll use the cyclo there. Then word root, so number of the carbon present in the structure, on the basis of that we need to give the word root. Okay, for example 5 carbon is there, so we need to say pent. Then for the 1s suffix, s for suffix, so type of bond, whatever the type is there, single, for the single bond we need to say n, for double bond we need to say in, and for triple bond we need to say ein. And apart from that, the functional group is there, so we need to mention the suffix of functional group. So one by one here we'll discuss about the these prefix and suffix. So for the prefix, you can see the table I have given, that is Br for bromo, for chlorine we'll say chloro, for iodine iodo, for methyl we need to say CS3 for the methyl, I for iodo, NO2 means nitro. So these name we need to use as a prefix. Yes, and I have told you for single bond N, and for double bond in, and for triple bond ein, these are used as a suffix, yes, before the functional group if they are present. Then here we have four functional group. So first functional group is the carboxylic acid. Yes, you can see the formula COOH or COOH. You should not confuse some of the time, like the COOH you can find, and like this structure you can see. Yes, so both are the carboxylic acid only, and for carboxylic acid we need to use oic acid as a suffix. Then for the aldehyde we need to use CHO. Yes, both are the aldehyde only, and for aldehyde we need to use L. Then third one is a ketone, so we need to use on, and fourth one is a alcohol, we need to use all. Now student, I have given three example to make you understand. Yes, so in the first example you can see I have used that carboxylic acid with the double bond. Yes, so we need to give the number. If we need to give the number of the carbon on the basis of the functional group, if functional group is there, so we need to give preference to functional group. If functional group is not there, so then we need to use we need to give preference to the double or triple bond. Then after that we need to use if double bond or triple bond is not there, so we need to see the prefix group if the heteroatom is there. So on the basis of that we need to give the third and last preference, we need to give to heteroatom. So first one you can see in the first first structure, the carboxylic acid is there, so that the first number I have given to the carboxylic acid carbon, then second, third, fourth, fifth and sixth. So you can see here on the second and third carbon having the double bond. So double bond and functional group both are present here, but we'll give the preference to the functional group. So because of that we need to start give the number from the functional group. Yes, then we'll see here the first one number is going to functional group, then second number is going to the double bond. But here you can see the double bond present between the second and third carbon, but what is there, we need to give less number to the double bond or the triple bond. Yes, we cannot give here 3. Yes, we need to give 2, least number of the double bond or triple bond. Then you can see on the carbon number 3 Cl is there, and on the carbon number 5 bromo is there. Yes, so as we start to give the name to this compound, so first we will write 5 bromo 3 chloro. Why 5 bromo? Because from the if we give the preference to the prefix, so we give the preference according to the alphabetic order. Okay, so that's why first we are writing 5 bromo, then 3 chloro according to alphabetic order. Then number of the carbon is 6, so that we need to write hex, and the double bond present between carbon number 2 and the third, so we will write 2 in. Okay, then at the carbon number first carboxylic acid is there, so we will write 1 oic acid. You need to remember, if in the functional group the carbon is present, so that carbon we need to calculate in our carbon compound. Yes, in numbering we need to count that. We should not forget to count the carbon of the functional group. Then in second example student, I have removed the functional group, and I am writing here the only the double bond and the heteroatom. So what is there? Because the from the right hand side, the uh, the double bond is getting less number. That's why I have to give the number from the same side, that is right hand side. So the same number we need to give. Yes, so what we need to write the name of this compound: 5 bromo 3 chloro hex to in. Okay, then in third one, what I have done, I have removed double bond also. So now you having the two condition. You can give the numbering from the right hand side as well as the left hand side. But if you give from the right hand side, so the chloro will get 3 and bromo will get 5 number. While here from the left hand side, if you give the number, so the bromo will get 2 number and chloro will get 4 number. So from the left hand side, the carbon the heteroatom getting less number. So because of that, we need to give the numbering from the left hand side, and the name of the compound will become 2 bromo 4 chlorohexane. So student, you can see, is the functional group is not present and double bond is not present, so we need to give the number or numbering from that side at which the heteroatom getting less number. Yes, and if for example in some of the cases these heteroatom are getting the same number from the both end side, so you can use any side. Yes, so this is all about the this video. Thank you.